All right, in this lesson, we're going to talk about how to find inverse for a one-to-one function. So if we are given a function, okay, we determine it is a function, it passes vertical line test, and we go ahead to find if it is a one-to-one function. If it is a one-to-one function, then there's an inverse, right? Inverse, whoops. There's an inverse. And there's unique inverse. Unique inverse. All right. Let me type it in a text form. Unique inverse. And we're going to talk about how do we find that unique inverse, right? But if a function is not a one-to-one, of course, we don't have to worry about it. We don't have to worry about the unique inverse because it doesn't exist. It doesn't exist. All right. Among all these 8 functions we have worked with, we know that some of them are inverse, well, some of them are not. Some of them are not, okay? So I'm gonna pick an example. So for example, I'm gonna leave this one for you, okay? This one doesn't have inverse, and this one is simple. I'm gonna leave that for you. I'm gonna find inverse for x raised to the power 3. We know this function has inverse, so I'm gonna take this entire function. I'm going to show you an example of finding inverse. For f of x equals x raised to the power 3. Okay, the general step. Okay, there are 2 steps. Okay, there are generally 2 steps, right? So we have this function. Okay, we have the function. We know it has the inverse, so we're going to set out to find it. So step 1, okay, we're going to rewrite this function as y equals to x raised to the power 3. It's just a simple substitution. It's just simple substitution. Okay. And then, okay, hold on. Step 1 over here. Step 1. Okay, we rewrite it as y equals to x raised to the power 3. Okay, the first step is that we swap. We swap x and y. So x and y swapped. Make the fonts larger. We swap x, y. And once we get it, right, after we swapped it, what do we get? The result of swap is x going to be y raised to the power 3. This step, not only just the swap of 2 symbols, right? X used to be the input and y was the output. Now the swap, x was from the domain, y is from the range, right? X is from the domain, y is from the range. The swap will cause the domain and range swapped as well. In this case, domain and range are the same, so you really don't see much of a difference, but it actually swapped the domain and range. Domain and range are swapped. Oops, swapped. Okay, so the domain and range are also swapped. In this situation, no difference, but in a lot of situations, there will be a difference, okay, when domain and range are not the same. And step 2, solve for y. Solve for y. If we solve for y from this equation, in other words, we say, oh, if this is true, right? Basically, we're saying if this is true, what is y? Express y. Okay, express y. Well, we can just take this, right? We're going to take a cubic root on both sides. We're going to take a cubic roots on both sides. And the result is y equals to cubic root of x. Cubic root of x. For this new function, we're going to have a name for it. It's called f inverse of x equals to cubic root of x. Cubic root of x. Okay, let me make the font just a little bit larger. You don't see the negative sign as for the inverse function. That's the inverse function. The inverse function found. Okay. All right. So here's the inverse function. Here's the inverse function. Okay, so that's how we find the inverse function. So we go back to look at the table. Now you probably understand why I put these two together next to each other. They are inverse function to each other. They are inverse function to each other. Okay, so let's look at the next one. No inverse. No inverse. Let's look at this guy. Okay, so let's look at this guy. What's the inverse for that? Right? Let's find the inverse for which function? This one. You can see it's very important that the whole time we attach our domain and range with us. Okay, we bring that along. It's very important. Every function will have its own domain and range, and domains and range will come with the function. It's like the shadow of the function itself. Once the rule is set, domain and range are determined. Domain and range are determined, and we must be aware of them all the time. And you will have to be aware of it all the time, especially you're on your way to take calculus classes. All right. So for this function, we know the graph. Let's find inverse. This guy. Okay. So we make y equals to root x, square root of x. Step one. Okay, swap. Swap x and y. Okay, what do we get? The consequence is x equals to root of y. That's a consequence of swap. And at the same time, what happened? Before the swap, right? Before the swap, okay? Before the swap, x is from the domain. I can say, well, x is greater than or equal to 0, right? How about y? Y is greater than or equal to 0, right? That's a domain and range. That's a domain and range, right? And after swap, they're swapped, but there's still this, they both have the same domain, and the domain and range are the same, but the swap is still taking place, okay? So they're swapped. So this y is greater than or equal to 0, x is greater than 0. So we still have x greater than or equal to 0, but their places have swapped. Okay, we have that tag along. Step 2, solving for y. Solve for y. How do we solve for y here? We're going to square both sides. We're going to square both sides. Oops, sorry. So we're going to square both sides, my bad, sorry. Square both sides. Okay, of course, still x is greater than equal to 0, y greater than equal to 0, that tags along, right? Well, that's after the swap. And then what? On the right-hand side, it's just x squared still. On the other side, it equals to y. Okay, so in the end, the inverse function is x squared. And then you may say, didn't we talk about that x squared doesn't have an inverse? Is this x squared the same as the x squared over here? Are these two x squared the same? This is x squared, and this is the and there's another one, right? Is this x squared the same as this x squared we have discussed? The answer is no, they're not the same. They're not the same. This x squared is under the restriction of x must be greater than equals to 0. Okay, so if you graph this function, it's only half of it. It's only one piece of it. So this function and the function right here, they are entirely different function. Okay, so to help us understand this, okay, I want to make it a comparison table right next to it. Okay, so this function without any restriction on x, which is domain is all real numbers, versus this one, they are entirely different function. Okay, and what will be the curve for this function then? Okay, the rule are the same. The rule are the same. Okay, but the domains are different. The domains are different. The domain here is x greater than equal to 0. That's the domain. It's like half of it. It's half of it. Ranges stay range are the same. Range is still the same. You see the difference? How about the graph? How does the graph look like? How does the graph look like? Right? The graph would just be half of it. Okay, it's not the whole thing. It's only half of it. Okay, let me delete these items. Let me see if I can make it work, okay? It may or may not work. Some software doesn't honor these. It doesn't do it. Okay, but that's okay. I know how to do it, how to work it. Okay, so this curve, what I can do is that I'm not going to show that piece. Okay, so that's the difference between these two curves. It doesn't have the other side. It doesn't have the other side. It only have one side. Okay, domains are different. The difference caused the difference in graphs. in graph. So these two functions are not the same, okay? And the latter is the inverse of square root function, okay? And so let's do the last function to find its inverse, and then we're gonna compare a graph. Okay, so the last function we're gonna find the inverse function for would be this one, yes. What is the inverse function for that? Right, what is the inverse function for that? Does it have inverse? Does it? Does it have inverse? It looks like it does, right? So we're gonna find the inverse for that function. Okay, and then what do we do? The same old steps, right? It's y equals to 1 over x. Be aware of the domain, right? Be aware of domain. X cannot be 0, y cannot be 0, right? X cannot be 0, even though these are the same thing, but we still go through these steps because there are cases that they're not the same. Okay, it makes a big difference when we swap. Step 1, when we swap, okay, so for this guy, when we swap xy, swap x with y, then we got x equals to 1 over y, right? And the swap caused the swap of x, y, and their domain and range swapped, but the domain and range are the same to start with. But we still write it down. Okay, y is not 0. That's a good habit. Always be aware of it. Step 2, solve for y. Solving for y from here, what do we get? Right, what do we get? We got y equals to 1 over x, which is flip both sides. Okay, look at this. The function and its inverse are the same. They look the same. They are the same. Okay, so the inverse function for this one, this doesn't happen all the time. Okay, among the 8 functions, there's another one which you have this property as well. Okay, so I'm going to leave that for you to find it. Okay, so we're also going to attach the domain. We're also going to attach the domain. Okay, so next, we're going to look at the graphs of the inverse of the functions that are inverse to each other, of the functions that are inverse to each other. Okay, we realize if a function has an inverse, right, it's 1 to 1, it has an inverse. The inverse is unique, so it's a pair. So let's look at the graph of them. So let's go back to the first one that we did, right? So this one has an inverse, and we have found its inverse is right here. Okay, these two are inverse to each other. Isn't it? Right, so let's look at this. Let's look at the graphs of functions that are inverse to each other. If they're inverse to each other, it means that if we put the graph together, what do we get, right? So let me put it outside, right? And this is the cubic root function, right? And then in the same picture, I'm going to graph f, right? I'm going to graph f. And that's going to be x raised to the power 3. And I'm going to use a different color. Okay, I'm going to make it red. Look at that. Okay. Well, for in this situation, we actually don't see very well because the scales are different. So I'm going to make some adjustments so that the scales are comparable. And that's how we see better. Okay. So please go ahead to do the same. You may like to make them the same scale. Okay. The black one is cubic root 3, cubic root function. And the red is x raised to the power 3. When we put them together, these two functions are inverse to each other. Okay, they are inverse to each other. Look like they're symmetrical along a line. Okay, as a matter of fact, it's symmetrical with respect to a line. Okay, let's make it green. Broken. This green line, okay, is y equals to x, is the inverse function are symmetrical with respect to. So if you fold the black, it's going to overlap with the red if you fold it along the green line. Is this the case for any two functions that are inverse to each other? The answer is yes, always, always, okay? So you can count on that. The inverse function to the pair of functions that are inverse to each other, their graph is always symmetrical along the line y equals to x. So if you fold one along the line, you get the other, you overlap with the other, vice versa, vice versa. Okay, so that's one interesting phenomenon. And next, what else pair that, symmetrical we have? Okay, what else pair we have? This piece, right? We know that this function is symmetrical with respect to what? Is inverse to this function, right? So let me put it over here. Okay. These two are inverse function to each other. These two functions are inverse to each other. Okay, I'm going to bring them down. Oh, we can just graph here, right? So I'm going to graph this one. Okay. And over here, wait, let me do this one. Okay, so then instead of graph this one, because we have those nice dots already plotted, right? So this is the root x function, and then we're going to have to just plot x squared on this piece, right? That's its inverse. And make it red. Boom. Okay, and we don't need the other red piece. We don't need the other red piece, so I need to chop it off. Okay, and then I'm going to make the scale a little bit better. See, the scale is not quite comparable. So we can work that. Okay, so I'm going to make them comparable scale. They're all in the first quadrant. Okay, are they comparable on scale? So this one, it's a little bit off. So if you measure, just measure by your eye, by our eyes, it looks like this one is the same as that one. So now we actually see the symmetry, right? And the symmetry along this very special line. Once again, symmetrical. Okay, so let me mark it. Okay, this is a root x, square root of x. And this piece is x squared. Okay, with x is larger than or equals to 0. And this line of symmetry is y equals to x. So these two functions are symmetrical along the line of y equals to x, the green one. Okay, this is also the pair of inverse functions to each other, right? Last but not least, okay, we just found the inverse for this guy, right? And we found that this inverse is itself, right? These two functions are inverse to, it's the same function. Are they symmetrical, right? So if we plot another one, right? So if this function, the inverse is the same as the function. So we're gonna get exactly the same one, right? So if we graph this function again, so you see both the function and its inverse at the same time. Is this symmetrical? Hold on, we don't really need this one. Is this symmetrical along the line of the green line, which is the line of symmetry? Yes, it is symmetrical. This function, the inverse of this function is the same as the function itself, right? So if you graph it again, you're going to get the same function. So, but this time we see both the function and its inverse in the same picture. All right, symmetrical. All right, so these functions has inverse to each other. Summarize. Okay, summarize. We go back to that 8 functions I once arranged for you. I once has arranged for you, right? Over here. Okay, so we have studied all of these functions. We have studied all of these functions, right? And we know that this has no inverse. It has inverse, we didn't find it, you're gonna find it. And these two functions are inverse to each other. These two functions are inverse to each other. We put them, together in the same picture. Okay, so I'm gonna bring that picture over here. There. Right here. They're inverse to each other, right? These two are inverse to each other. And no inverse, and this guy has inverse. Its inverse is, we just show that. We're just showing you that, right? It's a half of the, right here. That's not a very difficult summary to make, right? But it's important to put them together. So like that, just like that. Okay, so these two are inverse to each other. These two are inverse to each other. Maybe I would do it this way. Let's see, I make it so this will be better organized. Oopsie. Oh no, what did I do? I think I did I think I did, instead of augment the picture. Okay. That's not a big deal. I can fix it. Okay, I can fix it. Just give me a second. I can do it. I know what's wrong I have done. All right, so take your time to make sure you summarize this well. Okay, you summarize this very well. It's important. When we summarize, the work will look a little less. Okay, it should be here, right? And this is the inverse to the square root function. So I just want to bring them together. So I'm going to insert a column. I pressed the wrong button. And I'm going to bring these pieces together and put them over here. So this will be better organized. Wait. Yeah. What am I doing? Insert a column. And then I put it here. Let me save it. And like that. Huh. Doesn't do a good job for me. Huh. Okay, never mind. I'm not going to do it then. Okay. Inverse to each other. And this guy, the inverse is itself. Okay. So that's about inverse function and how to find inverse function if a function is one-to-one and the graphical feature of the one-to-one function. Okay. The next thing I want to talk about is the well, I think I'll probably talk about that next in another time, which is about the composition of functions, okay? Composition of functions. Okay, so I'm gonna save it for next time for another lesson. So this will not be too long and too crammed. And thank you for watching. Next time.